Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is related to the construction and quality control. Today also, I'm going to discuss about a very important topic, that is corrosion of reinforcement. If the reinforcement is corroded inside the concrete, eventually it will break the concrete and the structural stability and integrity will be in a problem. So in order to keep our concrete safe or the structure safe, we need to protect our reinforcement also so that it will not corrode. So what is reinforcement corrosion, and what is the reaction, chemical reaction of reinforcement corrosion, and what is the best practice to avoid corrosion inside the concrete? Today's video, I'll discuss each and everything. So stay tuned until the end to get the full information about the corrosion of reinforcement. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So let's start with first, what is corrosion? Corrosion of reinforcement, also known as rebar corrosion, is a deterioration process that occurs when steel reinforcement in concrete structure reacts with surroundings. So what is happening in the inside the reinforcement is there. So if any chloride in a sulfate ion or carbon dioxide and the moisture increase inside the concrete, so it will start reacting with the reinforcement and eventually leading to a formation of rust, that is iron oxide, on the surface of the reinforcement. This process can compromise the integrity and structural stability of the concrete structure over time. So what is happening when it is rusted? So the volume is increased, and if the volume is increased, the stress developed and the concrete become weaker and the crack develop. Other way, the section property of the concrete reinforcement also become weaker, so the tensile force carrying capacity of the concrete also become reduced. So that is why corrosion is very much detrimental on the concrete. So in order to keep our concrete safe, in order to keep our structure stable, we need to protect our corrosion concrete reinforcement from the corrosion. So we know what is corrosion. Now we need to know what is the chemical reaction of the corrosion, why corrosion is happening. The first thing, corrosion is an electrochemical process involving the flow of charges, that is electrons and the ions. So all we know though what is electrochemical process. For the electrochemical reaction, we need anodes and cathodes. It's the class 7th and 6th standard, 7th and 8th standard knowledge. So again, we just recapitulate what is electrochemical process. An electrochemical process is a chemical reaction that involves the transfer of electrons between two substances, typically through an electrically solutions or for a conductive medium. This process occurs at the interference of the two electrodes, that is anode where oxidation occurs, and a cathode where the reduction occurs, and this is driven by an external electrical current or the potential. So for the electrochemical reaction, what we need? Anode, cathode, and a solution or the medium. So what is the anode? Anode, the electrode where oxidation takes place. At the anode, electrons are released, resulting in the loss of electrons by the species being oxidized. So the electron release and that is oxidized. The same thing happens inside the concrete when the corrosion is happening in the reinforcement. We will see what is the chemical reaction, but for that we need to know this is the electrochemical reaction, and we need anode and then cathode, the electrode where reduction takes place. At the cathode, electrodes are accepted, leading to the gain of electrons by the species being reduced. So one is electron is reducing and another is accepting. And then what is electrolyte? And conductive medium, typically a solution containing ions that allows the flow of electron. Now from anode is the electron is released and the cathode is electron is accepting. Now how the electron will transfer, that is the medium is required, that is the electrolyte. So these are the process, that this electrochemical process, which is also is a process of the corrosion. Now at anodes, now what is happening in inside of the concrete, if there is a moisture ingress, chloride ion, sulfate ion, what is happening? There is an energy level of difference. So inside a concrete itself, the rebar become one side anode and one side a cathode, and this concrete or the moisture or the anything that becomes the electrolyte medium. So what is happened? The anode part of the concrete, iron atom lose electron and move into the surrounding concrete as ferrous ion. What is happening? The the iron is releasing 4 electrons and become 2Fe2. The 2Fe releasing 4 electrons, 2 of that become 2Fe2 plus 4E. What is happening? That is the main picture, or the how this electrolyte is happening. See here, this become anode and this become cathode because there is a energy difference. Now here what is happening? Here electron is releasing and that electron is accepting here and it becomes a ferrous oxide. Now and the next part is the electrons remains in the bar and flow to cathode where they combine with water and oxygen in the concrete. The reaction of the cathode is called a reduction reaction. A common reduction reaction is like that. Then 2He2O plus O2 plus 4E minus, that become 4OH minus. Now this 4AOH minus is developing because of the 4 number electrons which is released from the iron, and in the cathode part it react with oxygen, it become releasing the 4O hydroxyl ion but 4OH ion. Now these 4H ion, what will happen? To maintain electrically neutrality, now any medium is to become the electrically neutral. So it is the normal properties of any metal or any property, any substances. So it also become electrical neutral. So what is happening? The ferrous ion migrate through the concrete pore water to those cathode side where they combine to from iron hydroxide or rust. So these 4OH minus is again reacting with the iron and it is reacting FeOHO2. That is the iron oxide, that iron hydroxide, or it is rust. It's the powdery substance is deposited here over the surface, and we see it's a brown color and it is the rust. And if this rust is happening, again this cycle is happening. They are releasing 4 electron here, moisture is taking 4 electron and 4OH minus. Again iron is reacting and FeOH, the ferric hydroxide, is forming, or the rust is forming. And when the rust is forming, its volume is increasing and the mechanical properties of the iron become reduced and it is not carrying that much of tensile stress, and the crack develop inside the concrete, which is also implies that structural integrity in a problem. So these are the process of the chemical reaction of corrosion, what is happened inside the concrete. If there is a chances of ingress of water, chloride ion, sulfate ion, whatever, if it is ingress, again another part also, that this, if it is carbon dioxide also ingress inside the concrete, then again the corrosion can happen. That called is carbonation of concrete. That is another process. In the next video I will discuss about the carbonation of the concrete. So because of this ingress, and if the surface of the concrete is weak, then these all the element will ingress inside the concrete and the rust will happen. And if the rust will happen, our structural integrity will be in a problem. Now then we need to know what is the best practice to avoid the corrosion of the reinforcement. Now it is called the corrosion prevention. There is different ways we can make. That is the first thing, we need to do the proper mix design. Why? In the proper mix design, we will with the understanding that there will be no voids, there will be no air voids, and the proper compaction also there. So there will be no weak zone, that from the weak path, the the chloride ion moisture will not increase. The low permeable concrete, that is also to capture what is that the excess, the low permeable concrete, that means chloride ion, sulfate ion, and the moisture will not ingress into the concrete. Well, why? If it is ingress, that the corrosion will happen. That lower water cement ratio, which means if the lower end water cement ratio, that means there will be less free water inside the concrete, and it will also not react with the reinforcement, and it will not corrode. Then corrosion resistance rubber, there is a coating, that's a resistance coating, that's called corrosion resistance rubber, or the corrosion CR steel, that also we are using. Then corrosion inhibitors, that is another type of admixture we are inducing inside the concrete. It helps to reduce the corrosion of the concrete. Then adequate cover. Why adequate cover is required? Because whenever concrete is open or concrete in the structure, there is a tendency that from the intermolecular space, the water will penetrate inside the concrete, and it has a limit. So that is why it may be 15 mm can be enter into inside the concrete. So that is why the cover of reinforcement is required. If it is a 40 mm, that means a maximum water can penetrate into 15 mm, or the chloride ion can penetrate into 20 mm. So if the cover is 40 mm, so this ion will not reacting with the reinforcement. That is why the adequate cover is maintained. But in the site, sometimes it is neglected, but it is very much essential that cover should not be neglected in order to avoid the corrosion. Then proper placement of rebar. It is very much important. If the rebar is not placed properly, then again the corrosion can happen. Then proper placement of concrete and compaction of concrete. Why? If there is a void inside the concrete, and these voids, maybe the water and the other harmful chemical can enter, and if it is enter, again the corrosion will happen. Then curing of concrete is very much important. If the curing is not, then what will happen? The moisture inside the concrete, it will evaporate through the surface, and when it will evaporate, there will be crack. And in what this crack will be the weak path or weak zone to enter water or moisture and chloride and sulfate ion inside the concrete. And if it is entered inside the concrete, again the corrosion will happen. And the no crack on the surface. If the crack is on the surface is there, we need to protect, or we need to immediate action to cover the cracks. What is happening if the crack is there? Again the corrosion will happen. And the regular maintenance, that means the everything is need maintenance, as at the concrete also. So regular interval, we need to check the concrete. If there is any crack, if there is any discoloration, whatever, immediately we need to address the issue in order to avoid the corrosion of the concrete or the longer lifespan of the concrete. So these are the things about the corrosion of reinforcement. That is what is corrosion of reinforcement we discuss. What is the chemical reaction of the corrosion, or how the corrosion is happening, and also the how to prevent the corrosion of prevention. And also we sometimes we do the cathodic protection. So that means it will not help to release the electron ion. That is in a process, that cathodic protection. In this cathodic protection, we protect the corrosion of the reinforcement or the iron. So these are the things about the corrosion, and I hope you enjoy this one. And also you will follow all the guidelines of the concrete, so that your concrete has the lifespan and there is no corrosion of the concrete. And thank you once again for watching me, and please like and subscribe my channel. And I'm waiting for your valuable comment. From your valuable comment, everybody will be benefited. And if I want to know anything more about construction and quality control, please let me know. I will come with more content like this. Thank you once again for watching me.